Chapter 3 Track Structure Elements 3.1 Present Method Procedures of Maintenance of Track Elements in the manner complies with the policy set forth with Chapter 1 3.2. The criteria repair, maintenance, rehabilitation part presented in this part of the manual may pertain directly to the elements making up the track structure, and problems originated from the faulty drainage trackers and improper original construction. These problems may be solved in to or during the repair or rehabilitation. Competent engineering assistance may be required to resolve the determination of the cause of the deficiency beyond and the capability of maintenance force. The early attention of the maintenance problems reduce costly repair and add the efficiency of overall operations. Section 2, the ballast. The purpose of the ballast. The ballast is selected for the material placed under the roadbed. Purpose holding the track in line, elevation, and provide support, uniform support of the track, anchors tracks, and the supply drains of water falling into the roadbed. Heavy from frost retards the growth of vegetation economically for actors as much existing work is considered by the determining the type of ballast material and for the maintenance use. 3.4 types and size of application. 3.4.1 Crushed stone, slag, and gravel ballast are high strength, durability, permeable. Crushed stone, slag, gravel, similar to materials made by used by the area requirements, grading, graduation, wearing, or soundness, and coarse graduation up to 2.5 maximum sizes preferred. 3.4.2 Pit run gravel. Pit run gravel is satisfactory for low use trackage where crushed stone or high quality material is required for the running track. On 1 week of subgrades, free drainage sand is used as sub-ballast to reduce the pumping and formation of bullet ballast pockets. 3.4.3 The size of the table. 3.1% maximum minimum sizes recommendation of the ballast materials. 3.1 recommendation ballast graduations. The type: crushed rock, trap rock, limestone, slag, broken and screened, gravel screened, wash screened, and pit run. Crushed rock, trap rock is 2.5 inches in maximum size by minimum size of 3/4%. Fines allowable by the weight 10. Limestone 2.5 inches by 3/4 of an inch. Permissible fines allowable by weight 10. Granite 2.5 inches by 3/4 inch by 10. Slag and broken screen 2.5 inches by the minimum size of 1 and 15 on the weight. Gravel screen and wash 1.5 inch by 1/2 inch and 10. Screen 1.5 inch by 20. Pit run large rocks and remove 3.5 reconditioned ballast and stone slag. Ballast shall be cleaned in the dirt enough to grow vegetation for when the other foreign materials restrict proper drainage. Pit run gravel and high with fines exceeding 30% shall be replaced. Hand methods. Mechanical means may be used by reconditioned ballast, the stone slag, screen, gravel ballast. To recondition the ballast track, the following steps are necessary. 3.5.1 Clean ballast shoulder down to the subgrade to the sub ballast of figure 3.1. Here on 3.1 you see a slope of 2.2 to 1 and 6 inches to the tie. Off the tie, and then 56.5 inch gauge between your rails, and you got your C and your C total variable, and a 10 maximum off the slope on your second from the top ballast. On the sub ballast you have 48 to 1. On the ballast section 2 you just see the ballast, and from here, from A to the tie, instead of a top ballast and a sub ballast, you see ballast section number 2 below the slope of 2.4, with an 18 minimum off the side. Usually they use off the top of the rails over to the side of the ballast. They use what is called blue staking. And figure 3.1, the area ballast section, signal multi-track tangent. Back out. Clean the crib to bottom of the ties. Clean the space between the multiple tracks bottom of the ballast, or at least to 6 inches below the bottom of the ties. Clean the beam to the bottom of the ballast, preferable not less than 8 inches below the bottom of the tie. Clean the cross stretches and drains. Dress the subgrade, provide the drainage according to the minimum slope in the figure 3.2. Clean the ballast, remove, replace the clean ballast under the track. So add enough new ballast to make sure the standard section minimum ballast depth is maintained at 6 inches below the bottom of the cross tie. Correct the refuse material distribute and along the slopes of the fill. Pit run ballast to recondition the pit run ballast. Following the steps are necessary. 3.2.1 section skeleton lines the track is stripping on by rising the track on the old ballast. Figure 3.3 remove the ballast from the outside of the track to the original depth of the ties. Dress the subgrade wooden cuts and fills with it. Whether necessary, maintain 2.1 maximum slope, preferable 3 to 1. Facility maintenance. Clean existing cross drains and construction. No ones. Be sure to draw enough to provide adequate drain. Never locate cross drains and rail joint. Distribute enough ballast to provide for the lift of width and desired. 3.5.2.6 resurface the track uniform grade. 3.2.7 collect refuse material and place it along the slope of the fills. 3.6 distribution of the ballast. Expect the distribution of the ballast is needed in the intended raise of the outface of the track is surfaced and before the distributed of the new ballast. 3.6.1 the dumping is usually unloaded. The dumping of the hopper cars is unloaded by having one or more cars open at the top, allowing the required amount of the ballast to flow out as the train is moved along slowly, spreading and loading the materials as leveled as means of ballast. Plow and spreader can must be taken to hold and to the established grade and set for the new material. Hand methods require special attention to the placement of the ballast under the tie of the full length. Tamping the ballast must be packed within the hand tools of the machines. Figure 3.7, 3.8, and 3.9. 3.6.4 frog guardrail switches and turnouts. Remove all excess of the frog's guardrails and movable parts of the switches. Trimming the ballast. Ballast should be trimmed to conform to the standard ballast section. Figure 3.1 to 3.2. Appropriate template slopes are shown as preferred. However, the sections continue to require different slopes. The portion of the subgrade outside of the ballast should be left out of full enough of the surface and shoulders and embankment clearly defined as proper dress as the standard road. Right here you have a tangent single track. You have your 16s across from the off the top of the ties and into the ballast, which is the 3 to 1 ratio fill. There's 2 inches off 2 inches off the drop of the cross tie. There's a 1 foot and by a 3 foot cut out and 1 foot by a 3 foot raise. They split the track. The cross is 8 by 8 foot by 8 foot and 16 foot. It's a subgrade. It goes 8 foot by 8 foot and 2 foot by 4 and force. Curved track, they have 18 foot, 10 inch by 10 off by the 8 foot, and it is raised on a 2 inch grade. The ballast subgrade 3.5 ones, 1 foot and 6 and a set 1 foot by 1 foot and cut out. The 3.1 on the subgrade of the ballast 2 foot and a 4.25 inches. See a double track tangent and 2.5 by 1.5 inch in the center. You see 2 4/4 off spacing between from the start of the foot subgrade fill to the center of the track. You have 8 foot. You see 2 4/4 in the center of these, and center to center of the tie, 8 foot, and then 13 foot to the run of the double track tangent, which is 29 feet, and then 2 inches on the ballast is increased or decreased to the rise. 1/6 and 1/7 and 1 foot and cut in 1/3. 3 to 1 cut. 31 feet, 10 foot by 13 foot optional curve of the double track, 2.5 feet by 4.5 foot, 2.5 foot by 2.5 foot in the center, 2 foot, 2.5 and 1 by 1 ratio of the ballast. 2 foot rises, 2 foot drops. 2 inch foot rises, 2 foot drops. The sub ballast and the grade 3.1 and 3.1. Standards. Track skeletonized to receive the ballast. Wake section and cleaner rack berm surplus left over the trimming should be disposed as of an appropriate area. Clean up after the ballast cleaned is renewed. Remove off the all materials tool and equipment used to perform the work installation securely. Prompt all stock guards crossing plank similar facilities adjacent to the forming of the track, disposing of all rubbish waste material in the operation. Do not litter of the right of way. Section 3 ties 3.7 the general railroad tracks of the military installation has been constructed by the wooden ties. The use of the wood as the ties will be continued, but the circumstances use of concrete ties may be warranted. Trackage construction of the concrete of the recent years of several commercial railroads, indicating that some potential advantages of the concrete and over the wood ties are included in the use of long life, greater strength, and better ability to hold the rails permanently in line of the gauge. 3.8 of the wooden ties of the wood ties depends on the kind of the method treatment and mechanically protection afforded at several severity use of climatic conditions and untreated wood ties no longer than justified. Untreated wood ties are no purchase use design to specification ties and used in maintenance and repair and must contract the area standards federal specifications and should match in the existing adjoining work and see Appendix G. 3.8.1 Preventive treatment of the corrosion tie has been provided by the most effective practical preventive or decay or rot of insects. Damage to the wood fibers during the spike is less than treated in the untreated ties and water replacement. Section 3, the ties are, so we'll start at the top. They see the track skeleton ties. Waste section, clean of the rake of the berm. Surplus ballast left over the trimming should be disposed of and in the appropriate area. Clean up after the ballast is cleaned and renewed to remove all materials and tools and equipment used to perform the work. Install and securely properly all stock guards crossing planks similar facilities and adjacent of the forming part of the track. Disposal of all rubbish waste remaining of the operation. Do not litter of the right of way. Section 3 ties, 3.7 the new railroad trackage of the military installation have been constructed wood ties. The use of wood of most of the trackage use will be continued, but there are circumstances whether the use of the concrete they may be warranted. Tracks constructed of concrete ties recent years several commercial railroads have indicated some of the potential advantages of concrete over the wooden ties is no longer in use of life. Greater strength must better ability to hold the rails permanently to the line of the gauge. 3.8 the wooden ties. The surface life of wooden tie depends on the kind of wood, the method of treating, mechanical protection, affordable severity of the use of climatic conditions. Untreated wood is the tool. Treated wood ties no longer justified. Only treated wood ties are to be purchased or used design specification of ties and maintenance and repairs and must conform to area standards of the federal specification. Should match the ties existing adjoining working. See Appendix G 3.8.1 preservative treatment. Preservative treatment of corrosive tie have been proved to most effective, particular to prevent decay of the rot and damage of the wood fibers during spiking is less treated than untreated. During spiking is less treated than untreated. Water replenish is better as treated untreated ties. Coal tar, creosote ties, solutions of wooden tar, coal tar, contains oil-borne solutions of pentachlorophenol, pentachlorophenol are also most borne preservative. Use of the wood ties. Pressure treatment is effective than the field treatment because the preservatives applied for the pressure penetrated to the wood deeper uniform than they do applied to the field under no pressure. Constantly field treatment is raised only on and 2. Distributing and balancing from the hopper car. The ballast plow joint. Then we show hand placing the rails by mechanical distribution. Here you see Manual tapping within the compressed air tools. Machine tapping ballast. A large ballast tamper machine. Supply pressure treatment and whether it becomes necessary to penetrate the treated shells of separate shells of pressure treated ties by cutting edge, zooming, boring, and the resolution exposed untreated is to be the treated field applied chrysotite treating shell conform to the standards of the American Wood Reserve Bureau 3.8.1. Any fabrication such as trimming and required adzing and boring of the application, anti-splitting of devices, irons, figure 3.10, 3.11, and dowels in figure 3.12 show that performed before the ties are pressure treated and seldom are treated in shells that have been damaged, properly handled in place while the pressure treated and shells are unavoidable of damage and field applied and the preservative is to be provided. 3.8.1 because of the switch tiles uniform in length of figure 2.13 because of the location switch components cannot be predicted. Switch ties are not adds or bored and the pressure of treatment and the prefabrication of the switch tools shall be consistent with counting installation anti-splitting devices only. The field adzing and boring of the switch tie is to be followed by careful applied with the field preservative treatment. 3.8.1.3 in the field treatment is constituted of the two applications of the cresoto on the full untreated surfaces, whether they have been added or cutted or the material has shall be brushed applied unused on bore holes and spike holes filled and tight fitting as softwood treated plugs firmly driven into the holes. And that 3.8.2 handle wooden toys broken, bruised, gauge or otherwise damaged to the ties resulting in careless handling. Ties are not unloaded and dropping or throwing on the rail, rocks or hand or paved surfaces. Ties have been on the track. Tongs have tie handles with tongs suffered the loss of the damage of the ties handled within the bar shop. Tools figure 3.13 and 3.16 illustrate the proper method of hand wooding tools and the proper man in which is in stacks and within there are not to be used immediately. In the figure shown in figure 2.15 paragraph 2, stacks of the ties exposed to sparks other than fire hazard and protected covering the stacks either sand or 3.8.3 safety chrysotite of skin or irritant anti-splitters and constant hazardous handling ties. All personnel who handle the ties must be appropriate gloves. And figure 316 of the common hazard are the dropping ties or the heavy objects stripping or tools or supplies. All personnel are exposed to the hazard of the wear safety ties. These are anti-splitting devices, say as a nail plate and stuff. And these are black and white. They're hard to read. There's some anchors in the side of the wood. Anti-splitting anchors, a tie dowel. Typical switch type installation. They're doing. It looks like an outsplit face. Turnout. Installation of the tie wood and handles. Installation of the ties with handle tools. Here is a installation of the tie with a crane. Handle treated wood ties. Handling treated wood ties. 3.9 other wood decision. Other ties with wood are made in the qualified authority shall be based on the cooperative cost of the estimate aids reflecting all factors that are no longer used in concrete ties may be justified in their use of area inspection maintenance work entitled pavement removal and or at critical locations where the track maintenance work results in serious operational programs, the i.e. crossing paved streets, paved industrial area. There's concrete composite tie data and federal specification covering the concrete and composition of the ties have been completed. Meanwhile, specification for the ties will be developed in individual installation of those responsible engineering and military installations office higher than Echelon's energy engineering elements of the Department of Army and Navy and the Air Force. 3.9.2 the other materials are made of composite materials and state-of-the-art materials leading as a substitute and may be used available for proven in service. 3.9.3 handling concrete ties mark of the man-made or appropriate safety shoes of handling ties all that shall be unloaded and unloaded mechanically. Figure of the illustrates the proper the unloading concrete which are the ties to be stacked. They said to be stacked mechanically is in note ties shall be loaded, unloaded, or stacked by the hand. Because of the concrete weighs of nearly 500 pounds, all ties are moved in unloading of the stacks and works of the rail of the truck. The ties have been distributed, placed mechanically as closely as possible as the final position, then only they are manhandled into the position of the track work. 3.10. The current true tie inventories of similar military installations, including wood ties, non-standard dimensions such as the generally side of the tracks, permanent not running tracks. Future purchases are not included in the standard sizes of ties. Wood cross ties, the dimension trackage should be selected on the handling concrete ties should be selected on the track category paragraph to 1.9. A running access track should be at least 7 inches thick, 8 inches wide, 8 foot by 8 feet by 6 inches long. Ties of 6 inches thick, 7 to 8 inches wide, and 8 feet long may be used for low use trackage. An additional 7 inches thick, 9 inches wide, 9 feet long should be used as where the warranted or accordance with the area recommendations of manual 4 paragraph 411. Cross section ties dimension is applied between the 20 and 4 inches of the center ties and wood switch ties. The wood switch ties cross sections of 7 by 9 inches. The bill of the materials in figure 3.18 the lengths of 7 by 9 inches ties in the area of number 5 through number 20 turnouts. Wood bridges and ties. The lengths of wood bridge ties determine the design of the bridge, of which are normally minimum of length of 10 feet by the minimum cross section of 8 feet by 8 feet. 8 by 8 inches of cross tie. Maximum length of concrete cross ties is 8 feet by 6 inches. The figure 3.9 shows the typical concrete ties. Dimension of concrete ties slightly between the products different suppliers, but will conform generally to the same configuration. Concrete switch ties are not concrete. Available concrete bridge ties. Standard concrete cross ties may be used as bridge ties, which, when approved by a qualified engineering authority. Here's a picture of a typical concrete tie. 3.1 ties replacement reuse. In general types, you should not be replaced and used in decay. Mechanical be worn and mechanically worn beyond serviceability for purpose of intended. However, the general track reconditioned balance and rail removal is under the way of consideration. Should it be replacing the track and near the end of their serviceability, so the track need not to be disturbed again in the near future. Installation using the tie is normally confined in little light traffic temporary lines and siding and dead storage. Replacement usually considered a fouling and other priority. Running and access tracks, classification yard siding and storage tracks. And 3.11.1 spot replacement. Spot replacement is replacement of occasional defective small group of ties and no more than 10% of the ties in length of the track in which all other ties are in satisfactory condition. 3.11.2 general replacement. General replacement involves a large number of ties over 10% for a full length of track. Occasional ties and small groups of the ties satisfactory condition. 3.11.3 identifying the track ties and ties replacement will provide the inspection to have been completed effective and ties is marked in 3.220 and 3.21 remove the Chapter 7 and Manual FRA track safety standards and Appendix B. It describes defective due to the movable and switches and the switch. It must have been maintained better than conditions of the cross tie under ties under the